Thank you. So we are going to start the colloquium with the presentation by Danielle Burgess. And I'm going to briefly introduce Danielle. And it's a real pleasure for me today to introduce her to all of you. I know many of you know her. Danielle is a fifth-year graduate student who graduated summa cum laude with a BA in Linguistics from Cornell University before she joined our department in 2017. Her research areas include language variation and change, artificial language learning, language learnability, creoles and pidgins, morphosyntax, and the history of the English language. She has presented her work at a number of venues, notably her work on testing the preverbal negation tendency through artificial language learning at the Linguistic Society of America. Danielle has a National Science Foundation grant to study exploring the emergence of typological patterns through artificial language learning. So that was the title of her proposal that got funded for 3 years. And she has 3 publications so far, with the 4th one in preparation. She published a piece co-authored with 2 other authors on Creoles and Universal Grammar, published in the Routledge Handbook of Pidgin and Creole Languages. She also published a piece with several other co-authors on the problematic concept of native speaker of psycholinguistics that appeared in Frontiers in Psychology. She's currently part of the group that is working on a paper entitled Revitalizing Attitudes Towards Creole Languages, and that will be submitted to an Oxford University Press volume entitled Decolonizing Linguistics. And she will be preparing for publication what she will be presenting to you today. The title of her talk today is, of her presentation, is Investigating the NegFirst Bias in Learning and Communication. So back to you, Danny.
Thank you. Thank you, Marlies. I'll share my screen and get started. So as Marlies said, my presentation is titled Investigating the NegFirst Bias in Learning and Communication. So this is what I've been doing leading up into my prospectus, which I just defended last month. So I'm excited to share it with everybody, and hopefully I'll have a little time to share how I plan to go forward with it into the dissertation. What I'll start off with is just explaining what I mean by NegFirst. So I've taken this term from Larry Horn, who named this tendency. So it's the strong tendency for negative markers to gravitate leftward so as to precede the finite verb or other possible loci of negation. And this is a tendency or a phenomenon that we've seen observed and discussed in several subfields in linguistics, including typology, language contact, and language acquisition. And so as for what I'm going to talk about today, I'm going to go into that background about NegFirst tendencies in different subfields, as well as some of the limitations of that observational data, which leads into my experimental studies. So in study 1, which is my qualifying research paper research, I use artificial language learning methods to control aspects of the language participants learn to ask if there's behavioral evidence for a NegFirst bias in learning. And then in study 2, which just wrapped up data collection last month, I follow up on that first question again. And I also add an interaction phase to ask whether a NegFirst bias is driven by goals unique to communication. And then I'll have a little time at the end to talk briefly about what I plan to do next. So first, in the field of typology, research done on balanced typological samples have demonstrated a tendency for standard negation to be marked by a preverbal negator. And to be clear, this strand of research always codes the negator relative to the main verb. So that English would be described as a preverbal negation language here, even though negation always follows auxiliary do in English, for example. And Japanese would be described as a postverbal negation language, because this negative suffix follows the verb root. So this table at the bottom of the slide has the most frequent word orders, sort of based on areally and genealogically balanced sample of languages that Dreyer put together in 1988. So the most common word orders are highlighted in green, and it's helpful especially to look at the number of different language families, which are represented in each group, and they're listed in parentheses in this table. So what you'll see is there's a preverbal negation tendency, which seems to be somewhat stronger in verb initial languages, somewhat weaker in verb final languages. And so that typological distribution we saw on the previous slide has been argued to be largely explained by a branching direction principle, which basically states that languages tend to be head initial or head final, in conjunction with a sometimes competing NegFirst principle that I already discussed for negation to tend to want to be earlier in the sentence. But factors related to negative morpheme type also contribute to the greater variation we see in negation order among verb final languages in particular. So to put it simply, free particles seem to behave differently from bound morphemes, and this affects verb final languages more. So it seems to be the case that negative particles tend towards preverbal placement in both VO and OV languages. But in OV languages, negative auxiliary verbs and affixes tend towards postverbal placement, and OV languages are more likely to have those negative morpheme types than VO languages. But something which does still sort of point towards this NegFirst principle is that morphological negation seems to be more often prefixal than comparable inflectional categories like tense and aspect. And then to take a sort of much narrower typological scope, this NegFirst principle has also been brought up in Pidgins and Creole studies, where preverbal negation has been noted as a characteristic feature of Pidgins and Creoles. So this map is from the Atlas of Pidgin and Creole Structures online. And you can see languages that use preverbal negation are marked in red. So it's quite frequent among these languages that are studied as Pidgins and Creoles. And so this tendency in these languages has received quite a bit of attention because it does involve some deviation from common lexifiers of English and French. So we see 3A shows an example from Seychelles Creole, which is a French lexified Creole language, and that has the negator pas, which appears before the verb, but pas in French appears after the verb. But also, this negation, preverbal negation pattern has also been attributed to substrate transfer from, for example, West African languages like Yoruba and Gbe. So this example from Gungbe shows preverbal negation in that language, and these were present among speakers in these contexts, and so may have contributed. So these debates in this field center around this methodological issue of non-independence, which concerns all of language typology, but which is exacerbated with these like very restricted number of Pidgin and Creole languages and the contexts which contributed to them. So there's this, lingering question: is preverbal negation common because of a universal tendency, or because of factors of language inheritance, or is it multiple causation, perhaps? And then finally, in both first and second language acquisition, preverbal negation seems to be favored by learners and repeatedly appears in trajectories of learning, especially when the positioning of negation in the target language is variable or opaque. So in second language acquisition, we also see that language learners often show a tendency for preverbal placement of negation, even when both the L1 and the target language contain postverbal negation. So I'll go into a couple of examples. So this slide considers first language acquisition of English and German. These have both been very well studied. So in English and German, negation appears after the finite verb. And in acquisition, we tend to see children go through stages of clause initial negation and then preverbal negation without an auxiliary verb or with the verb unraised in German. And then finally, mastering finite verbs and putting negation often in a more adult-like place. And then this slide is also showing that we see similar trajectories in L2 acquisition of English, French, and German. So moving from clause external negation or constituent negation to preverbal negation to negation, which follows only non-thematic verbs, and then target-like negation that involves verb raising if that's present in the language. And then to move on to an example from outside Western European languages, Korean offers an interesting sort of case because in Korean, there are two ways of forming standard negation. So in the long form negation construction, as it's called in the literature, this is in 4a, the negator follows the main verb and attaches to an auxiliary verb to support tense, similarly to English do support. Whereas short form negation, the negation particle on appears before the verb. So Korean has both pre and post-verbal negation construction. And my understanding is that these two constructions are more or less deemed to be semantically equivalent, but there are some distributional differences maybe in which construction tends to occur more frequently with certain predicates. But what is interesting as far as NegFirst is that children acquiring Korean begin to use the preverbal negation construction much earlier than postverbal negation, though comprehension comes earlier than usage for the postverbal negation construction. And beyond that, Korean children will sometimes misplace the negator to be even earlier than it occurs in adult speech. So in adult speech, it's always the immediately preverbal position, but in child speech, they will sometimes put it before an object or adverb. And then in second language acquisition of Korean, this study shows that both L1 English and L1 Japanese learners in one study used significantly less postverbal negation and more preverbal negation compared to Korean adults. And so this is particularly interesting for the Japanese case because Japanese only has postverbal negation. So just to sort of summarize everything I said, a preference for early negation has been invoked or observed in typology to explain the cross-linguistic frequency of preverbal negation and prefixal negative morphemes, in language contact in order to discuss the prevalence of preverbal negators in pidgins and creoles, and also in language acquisition to explain typical developmental sequences which occur across languages and sometimes regardless of L1. So given these observations, which seem to point to a NegFirst tendency, something that sort of recurs in looking through the broader scholarship on this is an uncertainty about whether it's necessary to postulate an independent NegFirst preference or whether it can come out of other preferences and phenomena. So these other preferences could be things like harmonic branching and dependency length minimization, which already explains a lot of the typological negation ordering data alongside common pathways for the grammaticalization of negators. And then for the typological evidence of various kinds, there's an ever-present challenge of whether any given tendency is just an accident or like incidental result of the languages that happen to be spread and maintained and studied. And then when talking about acquisition data, there's this question about whether the trajectories we see in development, if they're actually related to anything about negation order, or if these patterns are caused by negation co-occurring with other difficult patterns in many of the languages we study. And then, so going another step as to like why NegFirst, I haven't really discussed yet why, what would motivate such a preference. One proposal that's been put forward is that there is a functional motivation to avoid delaying negation for reasons of processing difficulty. So Dreyer describes it here in a sort of audience design sense. So I'll read this quote. He writes, if a hearer fails to hear the negative morpheme in a sentence, they will have fundamentally misunderstood the sentence. Delaying them increases the risk of misunderstanding, creating a kind of semantic garden path, since the apparent meaning of the sentence up to but not including the negative will be the opposite of the intended meaning. And so contributing to the plausibility of this in the negation processing literature, it shows that listeners do sometimes consider the affirmative sentence in the processing of negation, especially when no felicitous context has been provided, leading to longer processing times for negative sentences. At the same time, when there is a felicitous context and expectancies for negation are already in place, then listeners seem to process negative elements quite quickly and easily. So this proposal put forth by Dreyer is somewhat dependent on like a worst case scenario approach to avoiding like worst case scenario negation processing. But it might be plausible, especially if we're considering context where learners are involved, learners who may be less apt to pick up on certain cues to negation. So my goals and research questions, I want to contribute to research corroborating typological tendencies with behavioral evidence at the individual level, in particular, looking at this NegFirst principle that has been proposed. And I want to test claims about the source of a NegFirst tendency being rooted in communication and processing advantages. So I briefly mentioned this earlier, but for study 1, which was my QRP work, I asked this confirmation question: is there behavioral evidence for a bias favoring preverbal negation in learning and production? And for now, I'm just looking at English speakers. And then in the second study, I sort of build on the first with some adjustments to ask that first question again. And then I also add this interaction component to question if a preference for earlier negation is driven by factors or goals that are unique to communication. So getting into study 1. So for this study, I ran 60 English speaking participants. There were 3 conditions. So this means 20 participants per condition. The language, the artificial language that participants learned had 6 animate nouns, 4 transitive verbs, and 1 negative particle. And the word order of this language was SVO. And negation could come either immediately before or after the verb. Either order was grammatical. And the way that participants were trained on the language was that they would see an image of an event paired with a sentence that described that event, and then they would hear audio of the sentence at the same time. So this slide gives a graphic overview of what a session looked like. So a participant was exposed to nouns, and then they were tested on comprehension with a 2 alternative forced choice task. And then they were tested on production. And then they repeated this process with affirmatives and negative sentences. And the trick was to look at the proportion of the negation order in production. So this is what a comprehension trial for an affirmative sentence looked like. So for this is the 2 alternative forced choice tasks. So they would hear and see Pipo Umidaki, which corresponds to cowboy punch boxer, and the correct answer would be here, just to give you an example of what the stimuli looked like. And then, so crucially, learners in this study were exposed to a language that had a mixture of the pre and post-verbal word orders. And the ratio of these orders was manipulated depending on the experimental condition. So those in the equiprobable condition saw equal amounts of both orders, whereas those in the other 2 conditions saw 75% of one order and 25% of the other. And as far as predictions, we know that humans tend to regularize irregular patterns in language. So all else being equal, we expect people to use the majority order more. And so the prediction consistent with the NegFirst bias is that participants would boost the majority order more when pre-verbal negation is the majority order, compared to when post-verbal negation is the majority order. because the equiprobable condition doesn't have the same input proportion as the other two phases, other two conditions, it's not clear how the amount of regularization might compare to the other two conditions. But it's useful as a reference to see how much and in what direction participants regularize in the absence of any particular skew to the input. So these are the results for study 1. So this chart shows the average proportion of majority negation order by condition for my QRP. So this middle bar shows the amount of preverbal negation that was produced by participants in the majority preverbal condition. The dashed line indicates the proportion of the majority order in the input, so 75% for this condition, and the points show the subject means. So averaging across participants, what we see, there isn't a large regularization effect in any group, but those in the majority preverbal negation condition produce just a little bit more preverbal negation, whereas those in the majority post-verbal negation condition were almost the same as the input. And so numerically, participants in the majority preverbal negation condition did use the majority order more than those in the post-verbal condition, but this difference in boosting wasn't statistically significant. And according to a logistic mixed effects regression model. So these results are somewhat inconclusive as to the presence of a bias. And what we see is that participants overall failed to really regularize. So going into study 2, I wanted to make some changes. So first I wanted to try to elicit a larger regularization effect. So it's known that increased demands on lexical retrieval increase regularization in adult learners. So in study 1, I had a word bank available to the participants during production trials, and I eliminated this for study 2. I also wanted to incorporate a task that involves communication. And the idea is that if the goal of communication, if the goals of communication play a special role in the NegFirst bias, as has been proposed in the literature, then learners may not shift until they're introduced to a communicative context. And to expand on that a little bit further, there may also be this pragmatic factor at play of, in a solo context, participants might feel that the goal is to demonstrate that they've learned by accurately reproducing what they saw in the input. But in a communicative game, with a little bit of inherent time pressure because someone is waiting on you, they might be more inclined to just do what works best for them while still maintaining accuracy in that task. So in this table, I've summarized the major differences between study 1 and study 2. So I added a dyadic interaction and post-interaction phase, which I will describe in a little bit more depth in a moment. I changed the constituent order of the language to move away from English word order. So it went from SVO to VSO. I removed the word bank in production, like I said, to encourage more regularization. And the study environment was also different thanks to COVID. So my QRP was conducted in the lab and this was conducted online. And so this is sort of just a reduced sort of study designed to show that there were 3 critical production phases. So the training portion of this experiment was quite similar to that of study 1. And in that training portion, there was a solo production task, which I'm calling pre-interaction production. And then participants were sent to a waiting room to be paired with someone else when they were done with training. And when that happened, they did a director matcher task, which I'm calling the interaction phase. And then they produced sentences on their own again in a retest, which I'm calling post-interaction. So before I go on, I'll explain how the director matcher task was set up. So once participants were paired in a dyad, one would be assigned a director role and the other the matcher role. And so the director was asked to enter a sentence to describe the image they saw and submit it to their partner. Then in order to both prevent communication in English or confusion caused by typos, the legal sentence that matched the director's input most closely is what was transmitted to the matcher. And then they selected the image that matched the sentence best. So for this sort of sentence, the matcher might have gotten a sentence that was sort of equivalent to punch, not cowboy, boxer. And the images they see an image of a cowboy punching a boxer and a cowboy punching an artist. And in this case, they would want to choose the image where the cowboy is punching the artist because the sentence means that the cowboy is not punching the boxer. So the goal here of having participants choose between sort of two affirmative event drawings was to test negative sentence comprehension, to test that participants understood the function of the negation marker without relying on this sort of negation symbol Q in the drawing. And also they were exposed to this sort of selection task earlier in the training before the interaction phase as well, and generally performed pretty well on it. So after the matcher chose an answer, both participants would see feedback after each trial about whether the matcher chose the correct image, and then they would switch roles and they switched back and forth for the duration of this phase. Okay. So moving on, sorry. Yeah. So as far as predictions, so there are two main questions here. And the first was sort of the same as the first study. So is there a NegFirst bias in learning and production? And the prediction here is the same, that if there is, we would expect participants to boost the majority order more when preverbal negation is the majority order compared to when postverbal negation is the majority order. And then is there a NegFirst preference driven by goals of, is it driven by goals of communication? If this is true, it would predict greater use of preverbal negation in interaction phase productions than in pre-interaction phase productions. So here are the results. This graph shows the study 2 data, and it's similar to the graph I showed you earlier, but now there's, in each condition, there's 3 production phases. So pre-interaction in green, interaction in orange, and post-interaction in purple. And so to explain, so in the equiprobable condition, this is showing NegFirst was coded as the majority order. So this is showing that in the equiprobable condition, participants regularized towards preverbal negation order to a much greater degree than in the QRP study, which is interesting. And then also in the other 2 conditions, in every condition, more preverbal negation was used in production, sort of across participants relative to the amount in the input. And so in this case, the critical comparison between these 2 groups did show a significant difference in the proportion of the majority word order use, which is consistent with the NegFirst bias. And then looking at the role of interaction, this director matcher task, you can see there's sort of a small boost in each group towards more preverbal negation. And looking at the pairwise contrast in each condition, the only significant difference was in this majority preverbal negation condition. And so I'm just at the beginning of my analysis and interpretation of the results of this study. But to me, this result doesn't seem to support the idea that communication like uniquely drives a NegFirst bias, at least for the task used here. Rather, looking more closely at what each pair is doing, it seems to be the case that in this condition, the majority preverbal negation condition, the participants were converging and aligning more than in the other groups. So I wanted to check if interacting pairs became more similar in their word order use during interaction. So this graph is probably kind of difficult to see, I apologize, but it's showing each interaction pair, the proportion of preverbal negation each participant produced over time. So when the lines pinch together, that's showing that the pair was producing similar word order proportions. So I calculated within pair difference scores for each pair at each production stage. And again, the only significant change in the difference scores from pre-interaction to interaction was in the majority preverbal negation condition in the middle. So yeah, still early in interpretation, but I think what might be happening, it seems to be the case that in this condition that was already skewed, there's more alignment and boosting. What I think might be happening is just more asymmetric accommodation, the role of asymmetric accommodation in that condition. So we have research showing that variable users of optional linguistic variants accommodate to categorical partners, but categorical users are reluctant to accommodate to variable partners. And what I think is that in the majority pre-verbal negation condition, there were more categorical users sort of at the onset of the interaction phase where the majority order was already aligned with participants' biases. And this led to more accommodation, asymmetric accommodation in this group. But so these are my sort of early conclusions, summarizing the results so far. So learners shifted towards producing more pre-verbal negation in all input conditions, which is consistent with the NegFirst bias. And then comparing the results we saw here, especially the pre-interaction results compared to the study 1 results, I think that there might be a role here of the increased demands on lexical retrieval and maybe distraction as far as participants were taking the study at home on their home computers. But there was also a different constituent order for the artificial language, so that might play a role too. And then I'm not seeing strong evidence for a special role of communication driving the NegFirst preference in this study, though I think the communicative context did induce greater alignment and regularization in the majority pre-verbal negation condition where the majority word order was already aligned with the NegFirst bias. So there's still more analysis to come for study 2, but one of the immediate questions I think that needs to be addressed next is whether the bias towards NegFirst we see in this study, if it is indicative of a universal preference for NegFirst in learning or a result of language transfer from English, because English, the negator always appears before the main verb, so maybe that transferred here. And so to address this question, I'm hoping to sort of extend and test this study with participants who are Japanese speakers living in Japan. And because Japanese is a strictly post-verbal negation language, this would provide a stronger test as to the universality of a NegFirst preference in learning. And then following up on the idea that a preference for earlier negation in production is linked to processing speed, I was hoping to, in the future, incorporate eye tracking, visual world eye tracking, probably as a method to examine whether individuals or groups who produce more pre-verbal negation also show slower comprehension when negation is marked later in the sentence. All right. And that's what I have for now. Thanks, everybody. And I'd like to especially thank my mentors and committee members. And then I'd also like to thank Sylvie, my cat, who supported me. And then I think, yeah, there's time for questions.
Thank you so much, Danielle, for such a wonderful talk. But of course, I'm kind of biased. So I'm going to, we have about 10 minutes for questions. And I'd like to, so first, I'd like for you to take note of the chat that you're getting while we wait for the first question. All right, so do you want to take that question?
Sure.
So there is a raised hand.
Oh.
Let's see.
Hello, can you hear me?
Yeah.
Okay, we can.
Okay, good. Awesome work, Danny. It's so cool to hear about this sort of all together. I was wondering if you had thought about, so like if this is a really strong bias, if you had thought about maybe having a group that's even more skewed towards post-verbal negation instead of pre-verbal negation, or like maybe both equivalent things. So like, I don't know, something like 5% and 95% or something like that, where the pre-verbal would really, you would think the pre-verbal will really seem like errors to someone who's learning the language, right? Like someone just, oops, made a mistake and didn't put it in the right place in the sentence, rather than being kind of systematic when it's 25%. Like that feels like, I mean, I haven't done your study, but it feels like if you have that many, that you might think that like, oh, there's something going on here beyond just like, oh, this person has made some errors. And I'm just curious, I'm wondering if, like, it would be interesting to see if you did something like that, if you still get that pre-verbal preference, because then you really are like, you're not getting 100% evidence for post-verbal, because I think if you did that, people would probably just match it. And then that's not really going to tell you anything. But like, maybe if you like decrease the variability, but still have a little bit of it there, it would be interesting to see if they still prefer the pre-verbal in that case.
Yeah, that's a really interesting thought. And as far as maybe a bias would show up in people sort of not discarding those sort of like one-off, very
right,
rare. Yeah, that's really interesting. I also think, yeah, maybe along those lines, I think it might be, because there are artificial language learning studies where people have manipulated sort of the amount of trust they put in the learning part.
Right.
So it was like, another learner produced this.
Right. Yeah.
Yeah. So that would be.
Yeah. I mean, I know a million more things to do. There always are, but I was just, that was one thing that sort of occurred to me. If you think that, and maybe that's sort of like depending on what happens with the Japanese speakers too, you can sort of see what happens there.
Yeah. Thank you.
Loretta, we will let you go ahead and call on people because things were not that clear on our end. Sorry about that.
Sure. So I think next with the raised hand is Charlie.
Hi, this was really cool. I was wondering about with the like when you gave them a negation sentence and they had to choose what picture it was, and they were both like positive sentences. The examples you showed were all the object was wrong. Was that the case throughout, or did you vary the incorrect and everything?
Yes, it was the case throughout, and I'm not sure if that was the correct choice. What I wanted to avoid was because it was a VSO order, negating the object.
Right, so it's farther from the verb.
Farther from the negation. Yeah, so I was sort of, that was sort of the intention. But I do think, yeah, it gets a little strange as far as like what the negation is doing there and whether it's like standard negation. And so, yeah, so I think that something that was suggested to me also, and part of the reason that I had the images, they were both, they were sort of, similar. They looked visually similar to the affirmative selection. But something else that was suggested is that I could do, if it's the cowboy's not punching the boxer, the negated version of that is that they're just standing next to each other or something. And so that is more negating like the whole verb phrase. But yeah.
Yeah, no, that's really interesting. I think you got into answering exactly what my other question was going to be, which was, could they be misanalyzing post-verbal as not object, say in study 1 or something? And I think, yeah, if you've had to control for that, and so that makes sense. So yeah, thank you.
Yeah, exactly. Thank you.
All right, Now we can call on Akriju.
Hi, Danielle.
Hi.
Great talk, very nice. I had a couple of questions going back to things that you were talking about in the typology review, which was great, by the way. So you're generally talking about the post-verbal negation just with respect to a single verb. And the question that arises there is, what role does inflection play as opposed to the lexical verb? So in that sense, like the clearly post-verbal negation would be negation following the lexical verb when you have complex verbs, right? And so there are questions about whether you would have a pattern by which, if you have two verbs, is negation following the first verb considered post-verbal negation or pre-verbal negation? And so that's a question that I think not all the typological literature took into account, right? And that might be relevant in terms of your study with respect to the interpretation of what the post-verbal negation corresponds to. And maybe we resolve this in the second experiment. I don't remember in the first experiment, was the order verb negation object or verb object negation for the negated sentences that were supposed to be post-verbal negation?
Yeah, it was always directly adjacent to the verb. So it was like immediately, it was verb negation object in the first study.
Okay, so yeah, so that sort of thing sort of raises a question about, so if you're thinking about it about an understanding of the underlying structure of the language, is that a pattern of verb negation object is normally aligned with a head initial order across languages, and that's indicated by the position of the object in final position. Whereas the clearly indicative of a negative final order would be verb object negation in the sentence, because that would align with the head final structure then. So what is representing post-verbal negation may actually indicate two types of underlying systems there. To which extent are those issues sort of coming through in terms of your consideration of the placement of the object?
Danny, you have about 30 seconds to answer. You have to be by 45.
Yeah. So as far as, yeah, I think so far as like the headedness of the language, that's not totally resolved here, I think, because if I'm understanding correctly, what I tried to do with the second experiment in particular was avoid having the negation next to the object, so that it would be like, but in the first experiment, as far as how they were sort of thinking of structure, if learners are putting sort of structure and on these, I think, yeah, I need to consider it more. And then also the multiple verbs thing is like a huge problem, but in the typology literature.
But your second experiment does show
Sorry,
quite a bit of that.
Akriju. It's time to switch.
Yes, thank you,
To our
Danny.
next speaker. Thank you. Thank you, Danny.
I want to join our chat and thanking Danny for just a wonderful talk. And I'm still processing it, and I'm doing so, but I have to shift gears to introduce our next speaker. So I get to introduce Justin, which is an absolute pleasure. We know Justin, you know Justin. Justin joined us in 2015. We snatched him from Google's ARMS, where he was served on a speech evaluator team. And prior to that, he completed both an MA and a BA at UCLA in their linguistics program. And he joined their program after completing an associate's in radio and TV production at Long Beach City College. Justin, shout out to Long Beach, right? And so Justin's research is at the intersection of phonetics and sociolinguistics, but I don't feel like I can use the label sociophonetician as an kind of academic category for him. Justin, to me, is a cognitive scientist of a kind of a classical breed, a breed that whose work delves deep into the structure of our cognitive system, recognizing that system is embedded in a rich and multifaceted social community. And this work recognizes also that to do this deep dive requires multidisciplinary skills. And those skills aren't just phonetic and sociolinguistic analysis. And I put just in scare quotes because there's no just about the rich toolbox that those disciplines provide. But his approach draws also from experimental and analytic tools from psychophysics. From his approach is guided by the philosophy of science and approaches in computational modeling seen elsewhere in the cognitive sciences. I think this breadth of scholarship, of interest, is on display in his record and presentations and in publications. This includes publications on the bidirectional interaction between speaker identity and speech perception, and a review article, I think impactful review article in Annual Reviews of Linguistics on language and discrimination. That article centers the active role linguists can and indeed must play in fighting discrimination in our field and with regard to language more broadly. All that work has been done in close collaboration with colleagues here at Michigan. I mean, it's just really striking to see this just the rich output that comes from the work that our colleagues do when they get together. So I'm not going to take up any more of your time, any more of Justin's time. Justin will be talking to us about work that is part of his dissertation. And this talk is titled "The Effect of Listener Experience and Social Expectation on Illusory Percepts." So thank you and welcome, Justin.
Thanks, John. Let me actually get rid of this Zoom window real quick. All right. So thanks, John, for both the introduction just now and for your and Pam's help thus far in getting to where I am today. Today, I'm going to be presenting one of the experiments from my dissertation, which broadly looks at the effect that listener experience and social expectation has on the perceptual content of illusory stimuli. So I want to start off with a short roadmap to give you an idea of where we're going today. I'll open with a brief, but I think necessary discussion about illusions kind of generally, with examples from both the vision literature as well as literature about the Gurk Effect. We'll then move on to research on social experience and how it can drive speech perception, because the work that I'm trying to tackle in my dissertation kind of lies where these two literatures meet with one another. So once that stage is set, we'll talk about what we hope to find at that.
Yeah. Sorry for the interruption. Do you want to be sharing slides right now?
I thought I was sharing slides, but let me try that again. Can you see them now?
All good. Yeah, super.
Sweet. So once that stage is set, we'll talk about what we hope to find at the intersections of kind of social experience, speech perception, and illusions. Let's see where I lost myself for a sec. And then we'll talk about what a test case would look like for probing what that intersection might look like, how it all comes together. Then we'll dive into the first experiment in my dissertation, the methods involved, some preliminary results that I'm currently working through analyzing and would love feedback on from people. So I'd like you to look at the two images that you see on the screen in front of you and ask yourself whether the top and bottom portions of the object on the left, which seems to be two pieces put together, whether those top and bottom portions are the same color. And I'd also like you to look at the checkerboard on the right and ask yourself whether squares A and B are the same color. So take a second to search your hearts, and once you do, I will regret to inform you that squares A and B on the checkerboard are actually the same shade of gray. When we connect these squares via a connector that's the same color as the squares, we can see this a little more clearly. A more exciting way to do this is to find this image online and then take screenshots of just portions of squares A and B and then compare those in your image files. Makes it a little more salient. I also regret to inform you that the top and bottom portions of the object on the left are also the same color. So if we cover up the center of the image, this becomes pretty clear for a lot of people really quickly. But if you're still on the fence, we can also cover up the shadow on the ground next to the object. And this might seal the deal for you, but if you're still unconvinced, we can also take away the contour at the top of the shape where our so-called light source is still perceivable. And by this point, this should result in you perceiving that the top and the bottom of the object are in fact the same color. So how is it that we get this so wrong? I would argue that we actually get it quite right, that given our experience in the world, we know something about the effects of light sources on objects. And it's worth noting that in these illusions, there are no light sources. There are contours, gradients of color, gradients of luminance, and even rigid categorical properties of objects like the pattern in the checkerboard itself. And yet when we interpret the content of these images, we interpret these details with an imposed light source that modulates how we perceive the color and luminance of these objects. And we make that light source in our heads. And illusions like these show that we impose some of the constraints from our perceptual experience onto new objects, even illusory ones, and that we know how to interpret whether these perceptual differences are products of a distal source or whether they're products of the distal environment. Kind of put bluntly, what you see is not necessarily what you always get. And one place that we see illusions within linguistics is the case of the Gurk Effect. This effect was first described by McGurk and McDonald 76, where they dubbed an audio signal of a speaker producing a bilabial stop, ba, for example, onto a video signal of a face articulating a velar stop, ga, for example. And when participants were presented these stimuli, they responded that they heard alveolar stop, something like duh. And this percept, specifically audio ba paired with visual ga, resulting in perceptual duh, is often called a fusion percept because it's argued to yield a percept which neither the audio nor visual signal would elicit if it were presented unimodally. However, it's also worth noting that this idea of fused percepts may be somewhat of a misnomer. Many studies have found that participants often identify visually articulated G as D or G as duh when it's presented unimodally. And I make this note because fused percepts have kind of long been discussed and theorized about in opposition to visually driven McGurk effects, such as the pairing of visual labiodental consonant like va or fa with an audio signal for a bilabial stop like ba or pa, as seen in the GIF on the right side of the screen. So if we put an audio signal on this, if you were looking at the left side of it, you would hear va. If you looked at the right, you would hear ba. All this to say, I'm going to be using the definition from Tapana 2014 that defines the McGurk effect as a categorical change in auditory perception induced by incongruent visual speech, resulting in a single percept of hearing something other than what the voice is saying. And crucially, what the McGurk effect shows us in linguistics is that in the course of audio-visual integration, visual information can take precedence and override auditory information. And two, that speech perception is not solely driven by acoustics. In the case of McGurk and McDonald and many subsequent studies, including this one, this precedence over audition is via vision. But Chick and Derrick 2009 and Ito et al. 2009 have also shown that somatosensory information can also override audition. Importantly, the McGurk effect percepts appear to activate the same neural bases and electrophysiological responses as veridical congruent speech stimuli, which suggests that illusory percepts that the illusory percepts that listeners experience may be perceptually similar or even in cases perceptually equivalent to veridical speech stimuli. And while the McGurk effect is robust to the point that it's maintained even when participants have been debriefed and are fully aware of how it all works and the perceptual processes at play, it's also susceptible to enhancement or diminishment by varying the timing of stimuli congruency, familiar and orientation of the face, congruency between the visual and acoustic gender of stimuli, the native language of participants. So while the effect is robust, it is left open to influence from other cognitive mechanisms. So I'm going to switch gears real quick. So that's one half of the literature that we want to consider. The other is stuff from the veridical world or the world in which we experience audio-visual information streams that are congruent with one another. It's widely understood that the speech signal not only conveys linguistic information, but also that the signal is interwoven with social information. And while historically this information was viewed as noise that needed to be overcome in service of linguistic interpretation, a lot of recent work has focused on how sociophonetic knowledge of the listener about the speaker who they are perceiving can be used to enhance that perception, which suggests that speech perception is malleable and kind of highly adaptive. In work with visual or contextual framing, providing listeners with information about a speaker, for example, prototypical sex characteristics that's communicated via a photo of the supposed speaker, will often result in listeners categorizing the same linguistic stimulus as a member of a different linguistic category as a function of that framing in which the stimulus is presented. Another similar line of research is match guise experiments, where socioindexical information is held constant by having a single bilingual or bidialectal speaker generate all of the stimuli, but for which listeners will assign different social valuations of that speaker as a function of the linguistic variables used by that speaker. So as such, as was the case with vision earlier with the illusions, it seems like, at least in veridical formulations, speech perception 2 is a case of perception under inference, where speech is not processed solely in a linguistic vacuum with invariant discrimination thresholds, but that listeners also incorporate aspects of the speech environment and the speaker themselves in their interpretive perceptual processes. So I want to play with a quick toy example real quick, partially to get you familiar with the image I'm showing you here, but also to get you thinking about how we're going to build some of the arguments here. So in English, the spectral peak frequency of a sibilant and speaker gender are related, such that male speakers often have lower overall spectral peaks, while female speakers generally have higher overall spectral peaks. While this has traditionally been analyzed as a product of differing physiology, recent research has suggested that this is an interaction of stylistic gender performance in addition to physiology. But no matter the source of the patterns, the entire continuum of spectral peak frequency is perceptually divided into an S distribution, a SA distribution, which is generally higher, and a SHA distribution, which is generally lower. And you see these labeled on the image on the slide, lighter for SHA, darker for SA. Now, when we look at the area highlighted in the yellow box, we see not only that these distributions overlap, but we also see that the category boundaries are not the same dependent on the perceived gender of the speaker. Thus, if we were to sample sibilants with a spectral peak from this narrower box that I just put up, we find that listeners make categorization decisions about what is a SA and what is a SHA with sensitivity to the gender of a face presented alongside the auditory stream. So when we sample from this ambiguous region and it's presented alongside a canonically masculine face, participants are more likely to categorize that sibilant as SA. And when that same sample is presented alongside a canonically feminine face, participants are more likely to categorize the sibilant as SHA, which suggests that while speakers use sociophonetic variables to cue aspects of their social identity linguistically in their productions, that listeners also play some crucial perceptual role when it comes to this interpretation, given that they can impute source characteristics onto a signal to resolve ambiguities. So let's take a second and cross the streams. So the sociophonetic perceptual literature tells us that listeners rapidly adapt to new speakers and appear to impose new perceptual boundaries to facilitate speech perception. Again, this suggests that listeners as well as speakers play a role in sociophonetic interpretation. On the other hand, the McGurk literature tells us that speech percepts are not solely driven by acoustic input, but can be overridden by visual information that result in their illusory speech percepts, and that the neural bases for illusory and veridical perception appear to be the same. Thus, it might lead one to ask how much acoustic information is necessary for listeners to arrive at socially meaningful percepts. Put another way, when listeners can't rely on the acoustic features in the signal to drive a percept, do their illusory percepts still reflect the variation present in their veridical speech experience? So to probe this, we would need to find a case of two languages or dialects that share similar phonetic features, but that are encoded onto different phonological categories with those features, and which are phonetic features within articulatory regions susceptible to the McGurk effect. And two language varieties that fit these criteria are English as spoken on the Indian subcontinent and English as spoken within the United States. In the case of Indian English, I think it's important to note that it is increasingly agreed upon that Indian English is a distinct dialect of English with a distinct kind of dialect internal phonological target, as opposed to the perspective that Indian English is simply received pronunciation as filtered through the phonology of a variety of Indic and Dravidian L1s. At the same time, to paint Indian English as a homogeneous and uniform language variety would also be disingenuous. In the same way that we see regional and social variation in American English, So too is this reported in descriptions of Indian English, most often with urban and educated populations being argued to display the most uniformity in their Indian English productions, but still a wide range of variety, kind of hinged in regional variations. Despite having different phonological grammars, though, American English and Indian English are mutually intelligible, and crucially, key substitutions between the two dialects take place in articulatory regions susceptible to the Gurk effect. I framed these in these slides from an American English perceptual perspective, partially because of the audience here today, but also because I think it's easier to talk about mergers and near mergers in the context of what two categories have come together. In the case of eth, or the, it's argued that Indian English exhibits a one-to-one substitution pattern where the dental stop is substituted for the interdental fricative found in American English. Some sources also discuss this being a retroflex stop as opposed to a dental stop. Nevertheless, stopping takes place. This pattern is well attested outside of Indian English as well. So it's not a unique feature solely to Indian English. It can be seen in other Englishes, such as the African-American English, as well as Uper English in the Upper Peninsula in northern Wisconsin. From the table on the right, these would be seen in pronunciations like the and duh, or breathe and breed. As for V and W, from an American English perspective, these appear to occur in free variation with Indian English speakers, given the fact that the labiodental approximant in Indian English exhibits both lip rounding and frication, though the frication does have less spectral power than American or British English the. Sources disagree quite a bit about whether this is an instance of full or near merger. And some sources even posit that V and W exist in opposition to one another, particularly in speakers who are well educated. And these sources argue that the less educated a speaker is, the more often the merger happens or near merger happens. At the same time, there are other sources as well that argue that phonological environment plays a role in the strength of frication in the labiodental approximant. And this frication seems to be was the most salient cue in whether it is perceived as V or W outside of this dialect. So these sources argue that rounded environments induce more W-like productions, for example, Volvo pronounced as Volvo, and unround environments preserve frication, resulting in pronunciations of words like waves as waves. And Silogic 2009 notes that we can see evidence of these two sounds being merged in orthographic representations as well, such as the movie poster for the film Guru, in which the tagline "Villager, Visionary, Winner" is composed to be an alliteration on the movie poster. So people seem to be aware of it. So I'm going to co-opt the graphic from the last toy example to build a new little toy example here. But this time I'm going to ask you to consider a scare quotes continuum, which spans two linguistic features that we'll call lip rounding and upper tooth protrusion, and that represent what could be thought of as distinctive features of the labiovelar approximant "wa" and the labiodental fricative "va," respectively, in American English. And it's worth noting here that this continuum is going to be different from the spectral peak continuum that you saw previously, and that I'm not trying to represent a continuous measure of acoustic energy or articulatory distance, but rather cognitive features that are distinctive to some groups of listeners, namely American English listeners, and non-distinctive to some groups of listeners, namely Indian English listeners. But we could imagine real-world cases like the words intervocalic or overworn, where both V and W are situated between schwa and O, both featurally round, and could consider where these tokens would be binned, given how the co-articulatory properties of those environments may spill over into those particular consonant productions. But to get you further away from the actual acoustic consequences of these features, I only want you to consider this continuum in terms of the visual signal. So thinking about what visual things you would need to see for things to be binned into these two groups. Because again, what we're curious about is the degree to which these visual signals facilitate illusions in listeners when paired with an incongruent audio signal, namely "ba." And once we have an idea about how listeners categorize these illusory stimuli, we can then probe the role of listener experience by asking the degree to which each participant group changes their categorization strategy after hearing the veridical speech patterns of speakers from each type of English. So we could ask, in these spaces where we're solving or resolving ambiguity between two dimensions, namely audio and video, as opposed to a single dimension, namely acoustic spectral peak, Do we see the same kind of inferential processing that shows imposition of veridical experience in these illusory conditions? Which leads me to a slide that didn't appear at first, to the two main questions of my dissertation, which are how are illusory stimuli categorized given the phonological categories of listeners in these two Englishes? And two, do these categorization strategies change as a function of listener experience? Or put more bluntly, given experience with a speaker, can a listener fill in the necessary salient acoustic cues that mark an accented speech percept for that speaker? So to probe these questions, I conducted a perceptual adaptation task where participants categorized McGurk stimuli before and after a 6-minute intervention video in which participants were exposed to the veridical speech patterns of the speakers in those illusory stimuli that they were categorizing. So stills from this intervention video are seen on the right side of the screen. In the video, I believe participants learn about what the Doppler effect is and how it works and the difference between transverse and longitudinal waves. So you can see some of it. Oh, my screen just turned off on my end. You can see some of the graphs down here, the Doppler effect up here, and I believe transverse waves, if I look over my notes down here. The experiment was designed and hosted on the online experimental platform Gorilla, and 200 participants, 100 American English and 100 Indian English were recruited using Amazon Mechanical Turk. Participation for these groups was limited via IP address to those residing in the United States for American English participants and those residing in India for Indian English. In the illusory portions of the task, stimuli were blocked by vowel, either ah or e, and place of articulation, either labial or consonant. Both speakers were present in each block, and participants heard 12 trials for block, 3 stimuli configurations. So always hearing ah ba, but visually seeing ah ba, ah da, or ah ga in coronal conditions, ah ba, ah va, or ah wa in labial conditions from both speakers, and 2 repetitions each. Upon listening to a given stimulus, participants completed a 3 alternative force choice task where they responded whether they heard ba, the, or da in coronal conditions, and ba, va, or wa in labial conditions. The stimuli that I made were comprised of audio recordings of vowel, consonant, vowel syllables, so ah, ba, and eb, respectively, and these were dubbed onto video recordings of vowel, consonant, vowel productions, consonant productions for eth, ga, wa, and va in each of the 2 vowel contexts. For the audio recordings, vowel duration, consonant duration, and amplitude were normalized to be the same between speakers, while speaker pitch and spectral burst characteristics of their voice bilabial stop consonants were preserved. And by preserving these characteristics, listeners were provided with acoustic cues to a speaker's social identity, but not acoustic cues to a phonological or phonetic category that they were going to be classifying or identifying, since they only ever receive acoustic cues for the bilabial stop. Thus, it's up to listeners to impose what they know about the speaker onto their illusory percepts to see if they categorize them differently. And because Zoom lags, these stimuli don't work particularly well when playing them from my machine over Zoom. So I'm gonna have a folder of stimuli dropped in the chat for you guys. Let me check the chat, not yet. Yeah, so it just got dropped in. So if you wanna look at these stimuli, I'm gonna be going over results from conditions with ah vowels, but all the ah vowel stimuli should be in there. So what might we expect from each of these groups of participants when viewing these stimuli? So in the case of American English listeners, we expect that they're going to enter the task with distinct phonemic categories for an alveolar stop, duh, and an interdental fricative, the, with an arguably distinctive visual feature of seeing the tongue protrude between the teeth of a speaker as opposed to being behind the teeth. Likewise, as discussed a few slides back in the toy example, we would expect American English listeners to have distinctive va and wa phonemic categories that are arguably visually distinctive via features for lip rounding or upper tooth, lower lip contact, respectively. And so if we pair these with audio ba, we would expect that we should get eth responses when presented a visual eth, V responses when American English listeners get a visual V, and we would expect a failure to McGurk in the case of W. And we predict failure in this case because American English W lacks frication. And as such, there's nothing for participants to map the acoustic burst of that B onto visually. In the case of Indian English listeners, we would expect that they enter the task without distinct phonemic categories for F and D, but instead have a single D category that they use in their substitutions. And likewise, we would expect these listeners to have a single phonemic category for the labiodental approximant V that has both visual articulations of lip rounding as well as upper teeth making contact with the lower lip. Now, again, if we pair these visual forms with audio of a bilabial stop, we would expect, in this case, greater D responses with the visual EV, given the substitution patterns of Indian English, and equal V and W responses with either the V or W visual cues, given the merger of V and W into the labiodental fricative or the labiodental approximant in Indian English. Particularly in the case of W, we predict illusory responses because the Indian English labiodental approximant has frication, and as such, participants could map the acoustic burst of B onto that visual articulation. So these give us our predictions for what we expect to happen within groups and kind of in the pre-exposure. What about afterwards? To start, we shouldn't expect to see differences after intervention when a participant is perceiving a speaker from their own language group. While there may be idiosyncratic differences within a speaker's veridical productions, their productions generally fall within the phonemic distributions displayed on the previous slides. However, across language groups, we should expect a few differences. The first is that American English listeners perceiving an Indian English speaker should have fewer ETH responses when cued visually with ETH, given their experience in the intervention with speakers' substitution patterns. Secondly, we would expect that V and W illusions to be roughly equal in categorization, regardless of visual cue, given the near merger in English. Essentially, we would expect Indian English patterns in our American English listeners. This would also facilitate more illusions within the Indian English speaker after intervention in the American English listener responses. As for Indian English listeners, we should say an increase in ETH responses when cued with visual ETH after intervention, as well as an increase in V responses when cued with visual V after intervention, given the distinctive role that frication plays in American English in cueing these differences. And lastly, just like we saw before with American English speakers in the beginning, we would expect to see fewer McGurk responses with visually cued W or W, given that the burst of acoustic B has nothing to map onto in American English. So I want to open the results with noting that what you'll see here are not results that have been statistically modeled because we're still very much in discussion about what type of model would be best for the data we have. And likewise, I'll be showing you results for illusions in a-vowel context, like I said before. What these graphs will show are average proportions for participants who McGurked at least 50% of the time during the experiment with standard error bars. So for these visualizations, that includes 63 American English participants of the 100 who McGurked at least 50% of the time over the course of the entire experiment, and 54 out of 100 Indian English participants. So thinking back to the study design, participants had two opportunities to respond to what they perceived for each stimulus. So average proportions were calculated by summing the illusions that a participant had to a particular stimulus, and then dividing them by the number of opportunities they had to have the illusion with that particular stimulus. So the two repetitions, essentially. Thus, if a participant had two illusions and responded both times with the same categorized illusion, they received a proportion of 1. If a participant had two illusions and responded once with one category and once with another, they had a proportion of 0.5. And lastly, if a participant only responded once with an illusion on the two turns, they too received a proportion of 0.05 for the half of the time that they experienced the illusion. On the left side of the slide, I've listed out predictions for how we would expect each group to categorize stimuli, with an ETH viseme in this case. And on the right, I'll reveal panels looking at how each listener group did in each stimulus condition. The x-axis shows pre and post intervention. The y-axis shows the average proportion. The horizontal faceting at the top shows viseme. And in this case, it's ETH and speaker condition with American English speakers on the left, Indian English speakers on the right. The vertical faceting on the far right side shows the groups of listeners with American English listeners on the top and Indian English listeners on the bottom. So if we look at the first block of graphs, if you remember the coloring from before, we see that American English listeners hearing an American English speaker categorize the stimulus that they heard as EV more often than they did as D. And then this was maintained across the intervention block, so in the pre and in the post, as is expected. On the other hand, when these same listeners heard Indian English speakers, that difference between responding EV and D seemed to decrease while still having more illusions overall. While these listeners had more illusions in post-intervention, their categorization strategy seems to have changed, as seen in the jump of the D responses. In the case of Indian English listeners listening to an Indian English speaker, we see what appears to be more categorizations to EV in the pre that dissipates after the intervention video. And while this is unexpected, I have some thoughts about why this might be, but I'll save them given time constraints on the talk. But if you're curious, feel free to ask afterwards. Lastly, in the case of the American English speaker, we see Indian English listeners responding in such a way that they appear to categorize the stimulus as EV more often than D. Again, this difference dissipates after the intervention. So we see on the left side, some places that I turned green, which are things we expected, and some things we didn't. In the case of the Bizime V, we see that American English listeners seeing an American English speaker are very sensitive to seeing the upper teeth make contact with the lower lips, as expected in their experience, and Illusory V before and after the intervention. When they are listening to the Indian English speaker, we see no effect of an intervention at all, as participants clearly still perceive an Illusory V before and after the intervention. In the case of the Indian English listeners, there's possibly a difference between categorizing the stimulus as B and W when listening at the beginning that again appears to diminish after the intervention. And this looks akin to what we saw in the pre-intervention trials with EV, just on the last slide. And lastly, when listening to an American English speaker, Indian English listeners appear to categorize the stimulus as V instead of W, both before and after intervention. In the case of W, I'm going to show you two separate graphs. So one thing that you'll notice is that we're not talking about V and W on the right-hand side anymore. In the first graphs, I'll show whether there was a difference in illusory or veridical responses. Illusory will be in black, veridical will be in gray. Because remember, part of our prediction here is that people are going to stop having illusions overall, and so they won't be categorizing in that case. And so on this slide, we'll look at how illusory responses were, or sorry, on the next slide after this one, we'll look at how illusory responses were categorized. So in the case of American English listeners hearing an American English speaker, we strangely see that American English listeners are experiencing more illusions after the intervention. This is unexpected, as we would have expected them to have a greater tendency to fail to McGurk, both in the pre and in the post. Yeah, John, sorry, you appeared on my screen. Oh, okay. When American English listeners perceive the Indian English speaker, again, we see an illusion increase. And in this case, we would expect this increase given that the burst of B can be mapped onto W, as argued before. In the case of the Indian English listeners, we see no difference in the average proportion of illusions when listening to the Indian English speaker. And in the final graph, Indian English listeners appear to respond with more veridical responses with the American English speaker after the intervention, which is what we would expect given that B can't be mapped onto W in this case, given the lack of frication in the veridical productions that listeners experience in the intervention. So, so when people are having illusions, how are they categorizing them? So oddly, in the case of American English listeners, with the American English speaker, not only appear to be McGurking more, as seen on the last slide, but are doing so in a way that suggests faithfulness to the visual articulation that they see. Now, how to interpret this is unclear in my mind, but further experiments that assess the quality of the percept, as in a percept that's being imitated by the perceiver in production, as opposed to being about category membership of the illusory percept, seem necessary and are in fact the next steps in my dissertation. In the case of American English listeners with the Indian English speaker, again, they not only had more illusions, but they also appear to have them in a way where V and W responses are the same. As for Indian English listeners with the Indian English speaker, they don't show a difference in categorization across the intervention. And lastly, in the case of Indian English listeners with the American English speaker, they don't appear to show a difference in categorization when having illusions. That was established on the last slide. They don't appear to be having as many. So to recap, American English listeners shift their categorization strategies with Indian English speakers in the case of visual EV post-intervention. And in the case of visual W post-intervention, they also changed their categorization strategies with American English speakers in the case of visual W, where they experience more illusions after intervention, but do so in a way that's unexpected. And again, this necessitates probing what these illusions sound like via something like imitation or shadowing. In Indian English listeners, we see shifts in categorization strategies with American English speakers and the unexpected decrease in ETH responses with visually cued ETH after intervention, but expected decreases in illusions with visually cued W. They also changed their categorization strategies with Indian English speakers across the intervention in the case of visually cued ETH and V with fewer responses in both respectively after the intervention. So ultimately, they end up where we expected, but started somewhere more akin to perceiving like American English listeners. So what do we take away from all this? There's a lot of stuff that I'm throwing at you. Assuming the results hold when being statistically modeled, I think there are a few takeaways that are really exciting avenues for the future. The first is that both illusory and vertical speech percepts appear to operate using inference in the form of listener expectation experience. And this should be somewhat reassuring and perhaps unsurprising given that the literature reports similarities in how vertical and illusory speech are processed. Additionally, perception at large seems to operate under the same principles of inference under uncertainty. And so we would hope that even speech illusions work in a similar manner. So if the results here are correct, it would suggest perceptual representations that are not only highly socially detailed, but detailed across audition and vision as well. Secondly, I think these results paired with recent sociophonetic perception literature are knocking on the door of something that I've been thinking about a lot with the phonetics lab, about a theory of listening styles, though I'll note that I don't like that name. And some of the things in this second bullet point will seem hand wavy as they haven't baked long enough in my brain. But if we're to take seriously the idea that sociolinguistic, or in this case, sociophonetic variables are underspecified and gain meaning in the context of style, as is canon in the third wave socio literature, I'm curious to know how much style making goes on the part of the listener as opposed to on the part of the speaker. So in some ways, this problem seems harder to tackle in that we don't get acoustic measurables for free like we would in a production study. And if listening style is simply another name for something like perceptual recalibration, then it's fleeting and it only seems measurable in schemes that look at before and after effects. But there's a real question about what that module would look like. Is it part of the perceptual system? Is it a decision-making module that utilizes the outputs of perception to feed forward into categorization? And where is it sitting in this thing that we call the language faculty? I think what I'm gesturing towards in a way is a question about how much imposition the listener puts on the signal from the speaker, and whether that's the same thing as hearing the intended variables that a speaker produces. And in a way, the results here suggest that you don't need to get listeners into a perceptual ballpark with the things that they hear in audition. You just need to get them sufficiently towards some multimodal signal that they can impose category boundaries on, given their perceptual experiences. And I would say that given the interconnectedness that socio-perceptual experiments are finding writ large between linguistic and social processing, I'm doubtful that if there is something like listening style, that its job is just to take in quote unquote real variables, or that such a module only operates over a linguistic representation. I'm running out of time, but speaking of representations, what of them? I'll throw some logs on the fire and then run towards the Q&A as it burns. First question I have is about multimodality in the sensory domain. If we take the results of McGurk and Jick and Derrick seriously, then there's the possibility that speech representations are not only auditory, but also have visual and somatosensory qualities in nature, which seems plausible given that they are a combined signal in the world. And likewise, much of the socio-perceptual literature is guiding us towards representations that are highly detailed in nature, albeit largely theorized as encoding details in the auditory signature. So if the results here bear out, we might be seeing that not only are these representations multimodal in the sensory domain, but also that the socially indexed detail that we see in auditory experiments might also pertain to these representations. Another thing that's harder that falls out of this is when does social experience modulate speech percepts? So if we go back to the Tapana description that I opened with, we need a categorical change in perception and a single percept of hearing something other than what the voice is saying. And so particularly in the W case, if we think about American English listeners McGurking more in the case of visually cued W with Indian English speakers, and the opposite, Indian English listeners failing to McGurk with the American English speaker. It seems like experience is in one case facilitating the creation of a percept, and in the other case impeding the creation of that percept. And at the same time, if you instead believe that all McGurk percepts are integrated, so you don't buy the Takana story, and that they're unitary in nature, then social experience might be modulating over categorization, and still you're just kicking the same problem down the road. So there is a question of when the social experience actually cues in and what it's targeting. Either way, I think there's a lot of room for future exploration when it comes to a theory of what listeners contribute and impose on the perceptions of the speech that they interact with, and kind of where these impositions take place along the line of speech processing in vertical and illusory domains. So thank you to you, and special thanks to Pam, John, David, Chandan, and all the labs I'm in.
Justin, thanks so much. Yeah, I only popped up on video in my role as mediator for the question session. We do have 5 minutes to chat, and I am afraid I'm not, how do I do I unmute? Loretta, do you unmute people? Oh, I apparently can do so now. So folks can raise their hands and jump in. Justin, do you take a look at the chat where the well-deserved praise is being, praised. Folks are ruminating, as they should.
As have you and I for like weeks with these, so there's lots of rumination.
Go ahead, Pam.
Okay, well, Justin, I've been part of those ruminations too, but
Yeah.
I want to since it was kind of quiet, I think partly because it was just so much information to take in, but John and I have had plenty of opportunity to take in this information with you.
Yeah.
So I'm just wondering maybe if you want to say something a little bit more about how your unexpected results can be probed by shadowing, because I think that might give a good preview to what's to come.
Yeah, that is a good question. So yeah, the next steps are to have people shadow both veridical and illusory stimuli in an effect to try and probe whether, so we think about this experiment as being about who are category members. The second experiment is how much variation is permitted inside of categories, essentially. So do people imitate illusory signals essentially the same way that they would imitate veridical signals? And I think that will give us a better feel. It'll definitely make clear what's going on with the American English speakers who McGurk more with W and McGurk W, whether that's just an artifact of, I got a crappy percept, I don't know what to make of it, but I saw lip rounding, so I'm going W. Or whether when they actually have to produce something, whether we just start getting buzz. And that kind of tells us that, sure, people are saying that's W, but it's clearly not.
Thanks.
I think we can tolerate one more minute if folks want to raise their hand. I want to ask in this moment a general. Oh, San has a question. Let me turn the mic over to San.
Hi, Justin.
Hey, Sam.
Great talk. I didn't quite catch it. So when the listener makes a choice, do they choose two IPA transcriptions, or what did they show their answer?
Yeah, so originally I was going to do something like that. And I was encouraged by, I think Samir Khan gave me the idea that in the instructions to give them words that they could like hold on to. So I believe in the instructions, it was something like, you'll answer TH, but this will be the sound like in the word father. You'll answer B, this will be like in the word rubber, etc. So in the instructions they got, here's what all the buttons correspond to. These are words that you've said before, but they just had regular orthographic transcriptions on the buttons.
Well, in that case, shadowing is really a great way to go. Especially if you think of the features, gesture-based features, you could either do it one way or the other. And that will really show up what exactly the listener is doing. Thank you.
Yeah, thank you, Sam.
I want to do three things in a reverse order as we wrap up here, which I think we are at time. Before recognizing and once again thanking our speakers, I want to ask if there's anything regarding the reception that we want to announce, or that I should already have known to announce. Is there, if there's something I should announce about the reception, please tell me now, or else I will move forward.
Well, we just have to remind people of where it's going to take place at the Michigan Union on the second floor in room 2210, so the corresponding to the ABC rooms, and it will be from 6 to 9.
Thank you, Marlise. Wonderful, wonderful. So now I need two more things. One is I'd like to thank again Justin for the talk we just heard and make sure we recognize that. And then separately, I need to again join together our whole community and thank both of our speakers for just a wonderful colloquium to wrap up this year and to just get our thinking going as we go into these holidays. I hope we can continue the discussion at the reception, and I'm just very grateful for this this wonderful set of talks. So thank you, and I thank you all.